We do it with our Schroeder diamonds. Our oil here, carbon compounds. Remember, what is carbon? Let's hone in a little bit here and get a close-up of what's going on there. We are going to get carbon is a diamond, right? Remember our diamonds? So this is going to go off. We'll just draw a little line here because these are continuous. So we've got one carbon bound to what? Another carbon. We'll draw the C's in there. So we're just going to use two of these. This would be the ethyl group off the end of that. CH3, what are the H's? These are our little dots, remember? So we got 3 dots. It's like something a court jester would have, right? So this is the ethyl portion of a carbon ring, carbon chain, I guess you'd call it. We'll write it up here with a different color marker, and we're talking about combustion. Combust ion. So combustion doesn't show up very good there, does it? Back up a little bit here. With the shine, it's not going to show either. Combustion is your carbon source plus O2. Now what is our O2s? O's are our circles with 2 bounds. That's O2. Carbon with O2 goes on to make CO2 plus water, H2O. How are we going to draw that? CO2 is simply a diamond and 2 for the O's. So here's 1 over here. 2 more on that. CO2. And what is our water? Simply O with 2 dots. It is that simple, kids. This is the combustion reaction. CO2 and water is what you end up with. Here's CO2 plus O2. CO2 and water. So this is really what it looks like. Could it get any simpler? And since we got it here, we're going to throw in an NO. Call it an NOx for simplicity. So what is N? N was our triangle, right? We've got a triangle. We've got an O, so that's 2 of the triangles. What would there be on there? Not an H, NOx. This is why it gets really confusing. What it would probably end up being is an NO. It's going to have an electron out there. So you've already got 1 pair of electrons there. This is one that would be like a semi-triple bond kind of thing going on here. So we'll draw some dots on that one. That's kind of like an alien with his 3 arms holding on to the oxygen. I was telling somebody I didn't want to go with this alien thing for nitrogen, but it really, really fits. So this is our NO. We'll draw this in blue here. NO, and we'll put an X in there. See, this goes beyond the introductory chemistry, kids. So even though I'm showing it to you, this is the stuff you don't need to know for even general chemistry. Carbon monoxide, they don't talk about the monoxide. They stick with the 4 bonds. They call it the tetrahedral character of carbon. So carbon here, if we'll use our hydrogens for example, got one hydrogen here. This is going to be a methane that we're making here, okay? What else do we got? We got another hydrogen here. And for you professors that don't think this is really applicable in college, you have bonding, anti-bonding orbitals with your molecular theory. So if two anti-bonding ones come together, they won't stick. But when they do meet a regular one, so what you learn from the methane here is see the way that they're evenly spaced around there. It's called tetrahedral. Carbon will always have this tetrahedral kind of thing going on. So methane, this is what comes out of the cows when they're out there combusting your sugars from the grasses that they eat. There's some bacteria in their gut that's making methane. And a big proportion of the methane, this is one of the pollutants, right? They're called greenhouse gases. I guess we'll have to distinguish between greenhouse gases and pollutants. But methane is CH4. CH4 methane. How do we do that with the diamonds? Simply one carbon and 4 hydrogens. 1 dot, 2 dots, 3 dots, 4 dots. Methane. Can it get any simpler? I mean, come on. Okay, and what are we combusting it with? We're combusting it with water. H2O, so here we've got an O. Usually always 2 bonds on the oxygen, so here we're just going to draw 2 dots. Now the beauty of this is when you have to balance the equation, because what you end up with, we're combusting it actually with oxygen. See, we'll have to go back here. I'm confusing everybody. O2 being the O double bond. So here's methane plus O2 is going on to make water. And CO2. So CO2 is going to be a diamond with 2 greens. There's 1, 2. This is the reaction. See if we can get this in here. Methane, CH4, and O2 is going to make CO2 and water. This is exactly what it looks like, kids. I'm not making it any harder than it has to be. H2O, CO2 from methane and O2. Now, isn't this artistic? I mean, I look at that and I'm like, there's no numbers other than the 4s and this stuff up here. The actual chemical representation of this has no numbers to it. So here's our methane. That's our starting product, starting reactant. The product we're going to end up with, CO2. Let me get these here. One. One of these has one, right? One. CO2. Hopefully not just CO, carbon monoxide. And water. I mean, what kid wouldn't be into this? It's just, you know, making balloons. Everybody loves balloons. And what is water doing when it's in a gaseous phase? It's bouncing around. So what you do is you half fill these with helium too, so that they float around the room. They don't fly away. So what does water really look like? If it's